Okay, I want to go through the math that's involved with exam number 4 in materials and methods. So there's one kind of problem where we deal with um, figure out how heavy a steel girder is, how heavy a steel I-beam or a C-channel section, structural steel members of various kinds. But we're going to be dealing mostly with a good old-fashioned I-beam or C-section. Um, C-channel shapes, those two kinds. But anyway, so, and then the other kind of math problem we have, a little more complicated, and that's dealing with how many squares of roofing, how much roofing do you need for a particular house, particular building? Because as estimators in construction management, one of your bread and butter skills is estimating amount of materials. And yes, I'm trying to give you at each one of these exams just a few questions of dealing with estimating quantity of materials a little bit to help you get ready for your first estimating class. It's just basically a primer, a little intro to this. And so that's what I've been doing in each one of these tests. And the actual amount of math that you have on a particular exam is pretty small. It's a percentage, maybe 5 or 10% at the most. So let's see. First thing I need to do is probably, I know. The first thing I want to do, I guess, is to switch to, no, I'm gonna go to the presentation first and talk about roofing, and we'll come back to steel. Steel is simple. That'll be the simple problem. So what am I doing? I'm clicking on share so I can find my PowerPoint and share the presentation on steep roofs. Okay, I forgot that when I brought this up, it went to the end. I had it on a page. So let me go down to the very end. Well, let me, no, not yet, not until I touch it. Okay, so now it's at the end. Okay, I'm backing up. So basically, I have two presentations dealing with roofing. And at the end of the second presentation is where I've got about 5 pages dealing with roofing areas and figuring them out. So the basic thing is that roofs are dealing with the roofs. When we're dealing with roofs, the material is measured in squares. So how many squares of roofing? That'll be the question you'll be asked. How many squares of roofing are required? But squares is just a shorthand way of talking about how many square feet are there of roofing. So when we're dealing with squares, 100 square feet is 1 square. And so if you had 3,500 square feet of roofing, if that's what you figured out, so that's what you're going to be doing, is figuring out how many square feet of roofing and then converting to squares. So if you had 3,500 square feet, that's 3,500 square feet. When you divide by 100, you'll get 35 squares. So the answer is 35 squares. 3,500 squares, there's 3,500 square feet, there's 35 squares. So all you're doing is moving the decimal place over 2 places to the left, to the left, to the left, 2 places. That's all there really is to dividing by 100. So from that standpoint, when you get a number, that's all you're doing is moving the decimal place over in the end. But you can take your calculator and divide the 3,500 by 100 to get your 35. There's nothing wrong with doing that. There's many different ways to solve problems. So in this picture that you see up on this page, I've got Snoopy on his Sopwith camel, his doghouse, and it's a traditional gable roof. So you remember back in chapter 5, we were dealing with various kinds of roofs. This is a simple gable roof like the one you see down at the bottom in that drawing in the picture, or the bottom picture. So the hard way to do it, and you might have to if you've got 2 different slopes or different slopes on your roof. Sometimes not all the slopes on your roof are the same slope. But in this perfect world that we're going to deal with, all the slopes are the same. And so then it's a simpler job. So first of all, the hard way to do it, you'd have to analyze that surface of that rectangle to figure out what's the shape on each side of that roof, what's the dimensions of that roof on its slope. And then you just multiply those 2 dimensions by each other, the number of feet along the length of that roof, and then along the slope of the roof going up, those two dimensions in feet, and you've got square feet. So that's all that we did here. But to find that slope on drawings, they don't give you that number on this along the rake of the roof, along that slope, running along the edge of that roof. You can see my arrow going along that edge. That's the rake of the roof, and you need that dimension, and it's typically not given on drawings. You're supposed to calculate it. They'll give you the horizontal. You can figure out the horizontal number, but you can't figure out the vertical dimension typically, or the horizontal. I mean, sorry, I got distracted. You can't measure along the slope. If you're out there in a real roof, you can just put your measuring tape on there and measure it, but on a set of drawings, you can't. They won't give it to you. What they'll tell you is what the slope of the roof is, and they'll give you other dimensions that are horizontal or vertical dimensions, but they won't give you a sloped dimension typically. I mean, there's no reason why they couldn't, but they just typically don't, and you don't have that information. You have to calculate it. So one way to do that is with Pythagoras' theorem. You can run along the and calculate that the a squared plus b squared equals c squared, where you've got a right triangle where a and b are the two right angle sides of the triangle, and then the hypotenuse is c, the longer dimension. So a squared plus b squared equals c squared, and then you solve for c. So we could do that, and you're going to need to know how to do that if you ever deal with oddball shapes, or you're dealing with numbers like that. But let me just kind of stay with this graphic here before I go to a piece of paper to describe any of this stuff. So here in this example, I've got a 20 foot by 40 foot roof plan, given that amount of roof. That's a slope. That's looking at from tip of the gable to the tip of the gable on the other side, so if you can, you really can't. If I change my cursor, I guess it would help, but I think that could cause me a trouble in another area. But from tip to tip across here, it's 40 feet or 20 feet across here. Okay, 20 feet, we're saying. And then along the side of that house, along the front edge of that big wide red roof on one side here, then you're looking at 40 feet along there. Okay, so 20 by 40. Well, if you go halfway across that gable, 20 feet, half of that's 10 feet. But along the length of that roof, that's going to be a different slope. So very often, we have some special triangles that you don't need to use a formula to know all the three sides of a triangle. And one of those is a 512 slope. You see that up at the very top of this page is here. Simple gable roof of a 512 slope. Well, a 512 triangle, a 512 slope is a special kind of right triangle where the hypotenuse is a nice round number. It's 13. And so us teachers like those numbers. So hint, hint, that can be helpful on an exam. It can be helpful in probably in your estimating course, it'll be helpful to know that special triangle. So us carpenters love that slope. It's an easy slope to walk around on, and the math is easy. You don't need to get all fancy. It's nice round 13. So for every horizontal foot that you're going horizontally across that building, the dimension, for every foot horizontally, you're going on that along the hypotenuse 13 inches instead of 12. For every foot that you're going horizontally, you're going up 5 inches. So if you think about this, it's a unit triangle where that's going on. Anyways, so basically, in this simple example here, for every foot you're going over 13 inches. If we're going up horizontally on this roof 10 feet over, well, then for every 13 inch, we're along the hypotenuse, we're going up 13 inches compared to 12 inches. So every foot. So that means it's that triangle or that slope is going to be 10 times bigger. So that's why I've got a rake of like 13 inches times 10 times we end up with 130 inches, which is the same as 10 foot 10, which really doesn't help us. We need it in its decimal form, which is 10.833333333 on the calculator. So if I should have probably just put a repeater mark on that or put a few more decimal places, but that's close enough. So that's our dimension. And so that down here, you get 10.83 feet. Oh, I can't highlight. I keep forgetting. 10 down here, our area on one side of that roof is 10.833 times 40 feet along the other side. And so on one side of that roof, you've got 433.33333 square feet. So, but we need both sides. So you double that. And now we've got 866.66666 square feet, which we probably round up to 9 or at least 8.7 squares. Typically, we try not to round up and introduce a bunch of rounding error in estimating until the very end. So we like to go figure out how much waste you're going to have, and you'll use certain rules of thumb numbers you might use on a very straightforward, simple roof like this. Maybe you might be able to get away with only 5 or 6% waste. Whereas if it's got a lot of corners and valleys and hips and stuff on a hip roof, well, then there might be 7 or 8, maybe even 10% waste. So you have to add that at the end, and then you can round up, but you try to be more precise with everything you do in estimating otherwise. But here we're just after the very simple facts. So I might have tried to round this up to, if you see 9 squares on there instead of 8.7 or something, well, then that's, 9 squares is it. That's close enough. You're definitely not going to order just exactly what you need ever. You're going to have some kind of waste, but okay. When you have the number of square feet on that roof, it can be handy for other things in estimating. And that's what I was pointing out down here. A sheet of plywood is a 4 foot by 8 foot sheet. So there's 32 square feet in each sheet. And so you could take that same number, 866.666 or 867 maybe, divided by 32, and you end up with 27 point plus something sheets, more than 27 sheets. So then you probably round it up to 28 sheets that you need. But so it can be helpful with the roofing underlayment. So in estimating, we actually use that number a number of places. Now, if you get to a more complicated roof, this gets to be a harder deal to do. So looking here, I'm looking down, plan view, the way the crow flies above your house or whatever. And this is looking at a little more complicated roof. It's a hip roof house. So you're looking where it says 28 feet here in the kind of, below, between A and C, you see 28 feet. That line along here is the top of the ridge, the peak of the roof here. And then you're sloping down the line here to along a hip, and another one on each side of B. There's another hip right here on the other side of A going down. And then there's a bit of a slope down to a lower ridge board, where you see 20 feet written here between F and D. And that's another ridge. That's a lower ridge. And then you got another hip going down, a shorter hip. So it might be a carport on the back here. And whereas the main house would be the main big area here. The point is, in order to analyze these slopes, especially if they were different slopes, is you'd have to analyze each individual shape separately. So the area of a parallelogram, the area of a triangle, the area of a trapezoid, you have to use all those formulas in here and play around with that. And so I've got a slope in here of an 812 slope. And so when I plug it into that a squared plus b squared equals c squared formula, where I'm solving for c, I ended up finding that that number is going to be 14. You see up here at the top where I got a cute little triangle at the very top here, that cute little triangle in the text here, under 8/12, 812 slope, 8/12 slope. It's an 8-inch rise for every 12 inches horizontal. All roof slopes are listed where the horizontal number is always 12 inches, which is a foot. And there's no accident that they do it that way. But anyways, so in this case, it's a weird number. It's going to be 14.4222 something. Maybe it's a little more oddball than that even, but close enough. So that slope is used here to and we're able to again figure out what the rake of the roof is, and I can go and analyze each of those dimensions. So I found over here next to A where it says 19.23 feet. Well, that's the rake of the roof, but this other lower roof has a shorter rake, and that one is actually going to end up being 14.422 feet long. So we can use all those dimensions. So that's what I did over here. So I'm mostly just giving you some appreciation of the math here, not making you do it, but it's best with a complicated roof if you got to analyze all these shapes to give them letters or something, especially when you got a whole bunch of numbers. So each area A, area B, area C, D, all the way around to F. And I figure out each of those individual areas. And you see, I ended up with a total roof area in theory of 2,884 square feet. 2884. And then, in a real problem, you would then add the waste. And I ended up figuring out 10% waste for this because of all these angles and the kind of roofing shingles and stuff. So I ended up with 10%. So that's 288.4 square feet. Well, close enough. 288. And then you can even get fancier in in a math problem and like this and have to add for hip and ridge caps, and that might be another 180 square feet. Basically, I know from experience that you get about 100 linear feet of hip and ridge caps from each square of roofing materials if you've got some 3-tab shingles that you're using. Otherwise, you got to figure out another way. And then we ended up with 3352. But anyways, it's 2884. Let's look at that number because that's the theoretical number about the surface area of this roof before you try to add any waste or anything else or mistakes, whatever. So look at that, 2884. So that's doing it the hard way. And I'm not going to make you do it, but I want you to see the easy button way next. So on this next page, I've got a simplified roof problem where we use slope factors. So SF for slope factor, you're going to see that in here. But basically, what you do is you calculate the area of this roof pretending it is flat. Now, you're going to have a problem on this test where I'm asking you to tell me how many squares of roofing on a low slope roof, if it's considered a low slope roof where it's a 212 slope or less, then all you got to do is calculate the roof as if it's a flat roof. So that's what you do. So in this problem here, that same picture down here, I left it down the bottom corner. It is, well, it's 60 feet across the front. And then on the way over on the right-hand side, you see it's 32 feet across that side. And so if you think about that rectangle, it's a 60 foot by 32 foot rectangle. So you have an imaginary line running across the back of that house. If the bottom of the picture is the front of the house, well, then the carport is out the back and all that. So yeah, I got to just take those dimensions. So 60 feet times 32 feet. So you see that up in step 1, the area flat is going to be 60 feet times 32 feet. And then that little carport piece at the back is 24 feet by 20 feet. So I have that in that same equation in step 1. So you get 60 times 32, and then you add 24 plus 20, and we got 2,400 square feet. So this roof area, if it's a flat roof, is 2,400 square feet. So that's that area flat. And if this was a low slope roof, that would be your answer. That's all you need. Just find the area of that roof. And if it's a simple rectangle, then it's even easier. Then that would just be whatever those two dimensions are of the roof, not the building. Because if you got an overhang, you got more roof than that. So if you had I don't know, in this house, if it has a 2-foot overhang, well, the actual building underneath that roof, instead of being 60 feet across, it would be like 56 feet because you got 2 feet sticking out on each end. So sometimes you got to pay attention to what the overhang dimension is in order to figure out what that roof dimension is. But anyways, we've got this 2,400 square feet. So let's look at step 2. We're going to find the slope factor. So in this particular problem, remember, we figured out already. And here's in step 2, it says, second, find the slope factor, SF. And so the SF is always going to be that hypotenuse of that unit triangle divided by the base, which is always 12. So C divided by 12. So we just have to find C. So in that A squared plus B squared equals C squared formula. If you take the square root of both sides, you end up with this formula like you see here, where C is equal to the square root of everything under that square root button would be A squared plus B squared, and then you take the square root of all that. And that's how we found 14.4222 something or whatever it is. It's a long number, but it's not a nice round number. So we take that number, and it's better to actually use the whole thing, whatever it is on your calculator, if you were to plug that all in there, and we divide it by 12. We take that 14.422 something, whatever it is, divide it by 12. And so I tried to keep as accurate and add a few extra decimal places to not introduce rounding errors in here. And we end up with now a number. It's just a number. It's called the slope factor, but it's 1.20185. And I think it keeps going, but that's enough to write down for any purpose, no matter what. So we can just take now in step 3, when you have that slope factor, once you have it, and I'll talk more about the slope factor and how to do that. But once you have that slope factor, now you just multiply that number, 1.20185. You just multiply that number times the 2,400 square feet that we found as if the roof was flat. So you see in step 3, it says, third, calculate the true sloped roof area. So you take the area, this flat, at 2,400 square feet, and you multiply it by that slope factor we had, that 1.20185. And we ended up with, when you use the whole number anyways, you get the same number, the 2884 that we got on the other page. So I spent a lot more time talking about this than you probably have to spend on it, but you basically got to take the slope factor. Now, little secret, us teachers, we tend to use not these weird ones that are going to require you to calculate such a simple number, but I'm going to use one of probably 2 different slopes in the test that are nice round special numbers. So the 512 slope is one of them that us roofers love a lot, or us carpenters, especially carpenters, but for framing and everything else. But it's a lot easier to walk around on a 512 slope. But there's another one that's a nice round number, and that's a 912 slope. So you'll find a lot of 912 slopes out there, because the carpenters and the roofers, they're all going to love that. It's nice round numbers to work with. And it's not as easy to walk on a 912 slope as a 512, but still, the math is still simple. For the 912 slope, the hypotenuse is 15. So it's a 9, 12, 15 triangle, where the hypotenuse of that right triangle is 15. So in that case, the slope factor is just going to be 15 divided by 12. If it's a 512 slope, that's a 5, 12, 13 triangle, where the hypotenuse is 13. The slope factor is going to be 13 divided by 12. So that's all there is to it. So let me go and try to get off of this page. I think, yeah, that's where I'm going to escape from, so I can go back to you looking at me. Okay, well, mostly so that I can go, and I'm going to toggle. I've got to switch to another camera. Oh yeah, we are. Okay, got my notepad here, and I need to move it over here a little bit. Try to give myself a little bit more. I've got a lot of junk on my table here I need to clean. Coming to the end of the semester, I'll get it cleaned up eventually here, but so let me get a little closer here so you can see it. Yeah, that should work nicely enough. Okay, so I wrote out some stuff here just to make sure to keep it from lasting too long. So let me back up for a moment, because it's a quick thing to deal with the weight of a steel member. So the one we're going to deal with is going to be an I-beam. But most I-beams, as we talk about in class, and we will, and I'll have, you'll be able to look at my other videos here for chapter 16, where I'm dealing with the roofing materials themselves. And we're going to be looking at the structural steel members and stuff. But under structural steel, we've already covered this, but it's W10 by 30 is a good example of an I-beam. Most I-beams are listed as wide flange, because most of the I-beams out there have a much wider flange than a standard flange, which used to be the thing. So a standard flange is no longer standard anymore. Wide flange is, but so So they literally designate on the drawings W for wide flange, and they don't, you're supposed to know that's still an I-beam. And then, so it's a W, this one's a W10 by 30. So what you need to know and remember, because there'll be questions where this can come up, is you need to know that the 10 means 10 inches, and it's the depth of that beam, or the height of the I shape. But we call it the depth, like you're standing on that beam. And so what's the depth of the floor underneath your feet? So 10-inch depth. So the second number tells you how much it weighs per foot in pounds. So sometimes we use the hashtag symbol. Back when I was a wee lad on the phone, we had the pound sign. Okay, so we often will use pound for pounds as a symbol, a little pound symbol, kind of like you see down here, maybe written a little bit better here. But anyways, so if you've got a 20-foot length of a W10 by 30, and that's the kind of problem you're going to get on the test, something like that, you need to know which one of those numbers, the 10 or the 30, is the weight. Well, what you need to remember is the last number. The 10 is the inches. The 30 is the pounds. So if I got a 20-foot length of W10 by 30, we're just going to go and multiply the 20 feet times 30, because it's 30 pounds per foot. So if you've got 20 feet of 30-pound material, well, 20 times 30 is going to give you your answer. So 20 feet times 30 pounds per foot equals 600 pounds. And that's all there is to it. So as long as you can remember which one of those numbers to multiply by, you're not going to have any trouble. And if it's a C channel, a C section, well, then it would be, instead of a W10 by 30, it would be C10 by 30, but the 30 would still be the pounds per foot. Now, it could be, a C section could be C12 by 15. And again, then it's 15 pounds per foot. Whatever the last number is after the by, the X or the by multiply or the by symbol, whatever you want to call it, it's an X, then that's what you're going to be multiplying by. If it's 30 pounds, or if it's 15, or if it's 140 pounds, whatever it is, that's the weight per foot. So you just multiply by the number of feet. Now, if I ask you, I could still ask you about what the depth of that beam is. Well, that's going to be 10 inches. So you need to know that too. That's the depth. If it's a C channel, it's the same thing. C section, they'll have a C instead of a W. If I ask you the weight per foot for angle iron, there's nothing in the way that they describe angle iron that tells you how much it weighs. You have to look on some other thing. So if that's all I give you is the dimensions, the basic, just, L 6 by 4 by half. Well, it's going to be 6 inches on one leg and 4 inches on the other on that angle iron. And so that's why they use the L. It's kind of an L shape, like an angle iron piece would be. And by half, it's ½ inch thick. Well, none of that tells you how much it weighs. You'd have to look it up in a book or something. So the answer to that question, if I was to ask you how much a piece of angle iron weighs, it's an L by 6 by 4 by ½ inch by half or whatever, that's ½ inch. They're all in inches. It's not telling you how much. There's not enough information. So the answer would be, who knows? Well, no, more likely not enough information would be the right answer. Not enough information to tell you what that weight per foot is. You'd have to get more complicated. So that's all there is in that math problem. You'll see that in the math quiz for math quiz number 4 that's dealing with the math here. And so you should make sure you do the math quiz, partly because then you get some points, but you can do it as many times as you want to make sure you really get it. So what we're going to deal with is now the other kind of math problem, which you're going to have more of. There might be 2 questions like this, and then you might have 3 or 4 dealing with number of squares of roofing. So if it's a low slope roof, you treat it and just call it a flat roof. It basically is flat. There's hardly any difference in dimension unless you're trying to actually cut the membrane or cut the steel. Then you got to do a little bit more complicated calculation. But otherwise, for estimating purposes, it's going to be almost insignificant, the difference. If it's a 212 slope or less, a 212 slope or 112 slope, a 1/4 inch 12 slope, all of those are legitimate slopes for roofs of low slope roofs. They're going to have a membrane. They're not going to have shingles. So in low slope compared to steep slope, first of all, with low slope, let's look at the problem. I accidentally used the same numbers as I had in my presentation there. So you'll find, so remember what factoid, first of all, a square of roofing is 100 square feet. So once you figure out how many square feet you have, you just divide that answer by 100. So here with low slope, I've got to stick this up a little way so you can see it. Okay, so we got looking down above the building. That's a plan view, and maybe I should write that on here. Plan view, which means, of course, if you're in the blueprint reading class like you should be this semester, hopefully, or already taken it, you need to take that course early. Then you know what plan view. You're looking from overhead above. So it's 40 feet the roof going one day and then 20 feet the other. So you just multiply those two numbers together for a low slope roof. You got 800 square feet. 800 square feet divided by 100, well, it's 8 squares. So that's pretty simple. Of course, I picked pretty simple numbers to make it easy. 2 times 4 is 8, and then the 2 zeros, you didn't even need to use a calculator for that necessarily. 800 divided by 100, you're just get rid of the 2 zeros again, Okay, so us teachers like nice round numbers like that. For a steep slope, let's go with the 512 slope. Sorry, there it is, 512 slope. I'm looking at the picture instead of but anyways, so now we need the slope factor. Well, the slope factor is just going to be this on this unit triangle, the 512 slope, those are the right angle numbers when we talk about a 512 slope. But this is one of those special triangles with a nice round number, so we know it's 13. 512, 13. In your career in construction, you're just going to have to know that number. So you might as well start memorizing it. It comes up all the time, in roofing particularly. So 13 divided by 12 is your slope factor. So I've got that here. Well, on a calculator, 13 divided by 12, you're going to take that number, 13 divided by 12 now, times 800 square feet. That's because it's the same dimensions here for this roof. Okay. Trying to give you enough to see what I'm writing here. And so, yeah, on your calculator, 13 divided by 12, and you end up with 1.0833333 times 800, and we end up with 866.66666 square feet. Okay, so it just keeps going. Then you go divide by 100, you end up with maybe 8.7 squares. Like if you want to, it might be a good possible answer. And so that's your number. And we could round it up to 9 maybe, but so it just depends. In multiple choice tests, if that's all you got as a 9 squares, and that's the answer. If it's 8.67, I don't know. That could be the right answer then. And so, in other words, I'm not going to trick you on this, but oftentimes in tests, I try to find numbers that are going to work out very, very close to a nice whole number. I can't always do it that way, but I sometimes do, whenever I can. And so if we were dealing with the other special slope, and that's what I got here, is this special slope right here, this special triangle. I'm running out of the capability to keep it on the screen here without holding on to the pad on my keyboard, so I don't type a bunch of gibberish on the keyboard or something. But anyways, okay, so another example of a 912 slope. That's the other special triangle that you're going to run into in roof slopes. And that's basically you may have heard of a 3-4-5 triangle. That's a special kind of triangle where it's 3 on one side, 4 on the other, and then 5 on the hypotenuse. Well, the 912 is a version of that, where the base of the triangle, where the triangle is 3 times bigger than that. So 3, 4, 5, each of those numbers on 3, 4, 5 are multiplied by 3. So you end up with 9 and 12 and 15 in the triangle. But that's because the bottom number, the horizontal number in roof slopes, always has to be 12. It's always 12 inches. It's a foot. And that's why we do it that way. So it makes a bunch of math easy. But what you need to kind of see in this little triangle, if you write the triangle out, and it's not a bad idea to do that with roof slopes, so you see it. And what you need is that slope, whatever that number is. On this special triangle is 15. You're going to be taking those two numbers, the 15 and dividing it by the 12. Up here, it was the 13 divided by 12. Those two numbers, one divided by the other. The bigger number, it's always going to be a number bigger than 1. Because think about this, a roof slope, if it's flat, well, you're just getting this basic square foot of a flat surface. Steep slopes, the steeper the slope is, the more roofing you need, because, the shortest distance between one side of the roof and the other is going to be a straight line. If you have to go up the roof and down the roof, you're using more roofing material. So we know before we even calculate that a 912 slope is steeper than a 512. So we're going to have more roofing material. So 15 divided by 12, we have the 800 square feet still. So 15 divided by 12 times 800, or else if you put 15 divided by 12 in your calculator, you get 1.25. So that's a nice round number. Times the 800 square feet, and we end up with 1,000 square feet instead of 800. So there's 200 more square feet in a 912 slope than a flat roof. Well, that's a nice round number. So that means move the decimal place over 2 places, you got 10 squares. So that's our answer. So the secret to doing these roof calculations, the roofing calculations, is to calculate the roof as if it's flat first. And then the next trick is finding that roof slope. So if it's a 512 slope, it's 13 is going to be 13 divided by 12, because a hypotenuse is 13. You need to find that hypotenuse of that unit triangle. 13 divided by 12 gets multiplied by that area, whatever it is. With a 912 slope, that's the other one that us mean old teachers like to use, because we feel so justified when we go and use a simple problem. We say, oh, it's an easy problem. Once you know the trick, yeah. But you could have taken, let me just take the piece of paper I just threw on the floor so I can use it right quick. Remember this formula. I think you're going to need this in your career. A squared equals B squared plus C equals. So if I write it this way, I've got funny reflections because I've got my background on, but it's giving you a little funny pictures here. But anyway, so C squared is equal to A squared plus B squared. That's Pythagoras' theorem, but I purposely put C squared on this side of the equation, because if you take the square root of both sides of that equation, well, the square root of C squared is just C. So C equals A squared plus B squared. So you got to figure out what those two numbers are, add them together, and then you take the square root of the whole thing, So if whatever your roof slope is, and one of them is going to be 12, by the way, always, the horizontal number will be 12. So whatever this other number is, plus 144, because 12 times 12 is 144. And then you add them together and you take the square root of that, and you're going to get your slope, your hypotenuse. And then you can just use it divided by 12. That gives you your slope factor. So this is a formula you're going to need a lot in your construction management courses. You might as well start memorizing. This is the form of this Pythagoras theorem that you'll use all the time in construction, because you're typically going to know what A is and B is, the rise and the run. It doesn't matter which one is which, but I'll call it the rise, the vertical rise, and this is the vertical run. Okay, I'm hiding it. And the run is always going to be 12 inches in roofing. And the rise is whatever it is, and that tells you how steep the roof is. So it's always the bigger the number, the steeper the roof. So, if 212 slope, that's nothing. If you put 212 and this together, 2 times 2 is 4, and 144, take the square root, you're going to get hardly any difference at all. So that's why we can just deal with low slope roofs as being flat. Pretend they're flat, because they're basically are flat roofs. They have to have a slope on them somewhere, so that that always happens. But that's all there really is to these math problems. So if I go back up to switch to my other camera for a minute, or maybe to the end here, and see if I can go share the study guide. I think it's still up here. Where are you? Yeah, there you are. There's a study guide for exam 4. You'll find it right above exam number 4 in week 15 or 16, 15, I guess. And so when you come down to, what page am I on here? It's page 6. Okay. And just a little bit further down, I start talking about these roofing areas on page 6 and on page 7. And I go through some of these problems, page 8. And so I'm working through some problems in here too. So you can use that for help too. And then of course you got the math quiz. And if you have any questions on this, please, feel free to, contact me with any struggles you have. But I know I started off a little slow here, but I think the repetitive nature of these problems helps a little bit. Let me just go back to sharing my screen again. Okay, that's what I have to do. I have to unshare. I'll get it straight so I can share. Oh, no, I wasn't sharing. I was trying to get to the other camera for a second. One more summary thing. So we're looking at the camera again. The first problem, you're dealing with the weight of steel of a member. So again, remember the first number in whether it's a W10 by 30 or whatever it is, the first number is telling you how many inches the depth of that beam is, the height of the eye. And the second number is telling you how much it weighs per foot along that beam. And so if it's a 30-foot beam, well, then it's going to be 30 times 30. It's whatever the number of feet is times whatever that number is tells you how many pounds you have. When you're dealing with the squares of roofing, remember a square of roofing is 100 square feet. And so you're going to figure out how many square feet you have on a roof along the surface of that whole roof. And then you're going to divide it by 100 to figure out how many squares, and that'll be your answer. If it's a flat roof, you just do the simple square footage of a flat plane. And if it's a steep slope roof, you do the same thing. You just figure out the area of that roof is if it's flat, and then you multiply it by the slope factor, which is going to be the hypotenuse of the unit triangle divided by the base. So it'll be something divided by 12. C divided by 12, if you want to give it a formula, because C is the hypotenuse of the triangle, and that's the easy button. And this works. And this is something that they may not even always teach you in estimating courses, but it's the easy button way, and it works. It's very accurate. It's as accurate as this number is. So if you got a weird number like I had when I had my problem I was showing you, where I had an 812 slope, it's not a nice round number. If I go and take on my old calculator here, let's see if I can put it on the screen at the right angle where you can see it. If I take, 8, I'm going to multiply 8 the hard way, 64, and I got 144 is 12 times 12. Okay, I'm not giving you the right angle here. There, maybe. Oh, it varies, huh? Okay. You don't need to see my calculator, I suppose, but it would be helpful. There, I just got to get it closer, and it works, sort of. It doesn't help that my calculator has kind of a bit of a green hue to the screen, huh? And I got a green screen going. But anyway, 64, I add them together. So that was a squared plus b squared, 208. So I take the square root of that, and I ended up with this. What you see is 14.42220510. It just keeps on going, whatever it is. But you could just leave that in there. The slope factor would be that number divided by 12. So I'm going to take that same number and divide it by 12 now. I can put it on the stack so you can see it. Those two numbers are going to get divided by, and it'll get this long, long number, 1.201850. It keeps on going. Just leave it in your calculator. And if you had, I don't know, we had 800 square feet, right, on this problem. So let's go and I'll make a copy of it, a couple copies. 800 square feet. We're going to multiply it. My calculator works weirdly in it, and this becomes your answer, 961.5. So 962, you might say. And depending if we needed to add waste and all that. But point is, the slope factor gives it to you. Now, if your roof slopes are just a little bit different, maybe. I mean, I've seen roofs that were, you notice when you walk from one that's maybe a 912 and you walk over to the next surface on a hip roof, and it's like a 10 or a 1012, and holy smokes, and it is a little steeper. But it still might not be enough for your estimating purposes, especially when you're adding a little bit of waste. You might still be able to ignore the factor. But if they're greatly different roofs, you definitely have to, different slopes, then you definitely have to analyze each of those slopes separately and go back to the fundamentals that I've got in that PowerPoint in the last couple of pages of chapter 16B. Remember, chapter 16A deals with low slope roofing. Chapter 16B presentation and the quizzes and everything deal with steep slope roofing. And so steep slopes, we can use shingles. Low slopes, we use membranes. And if you're in this gray area, I mean, 212 slope and less is a low slope roof. Then from then anything more than 212 becomes steep slope. But it's really not a smart idea to put shingles on a roof that has anything less than a 412 slope. And so the building code allows you to do it, but here in Louisiana, with the heavy rains that we can get, like we just had a lot of rain on continuous rains in a lot of places here the other day. Well, that's going to cause trouble with shingles anyways. You'll have water leaks of all kinds of, so what we have to do, and what the building code requires, is that you put a membrane down first and then you put your shingles on top of it. So you end up with a much better membrane. So you basically have to do both if you're going to go somewhere between the low slope and the steep and the 412. So anything from 412 up becomes a practical beginning slope for shingles. But you can still put them on a 2.5 12 slope. It's just you're going to have roof leaks. That's all there is to it, unless you really do a good job of doubling up and maybe even tripling up your roofing membranes, your underlayments. Okay, I better stop. So unshare. Oh no, I know, I'm not unsharing. I gotta bring it back to the other camera. I'll get it straight. Okay, call it a day.